Let's go ahead and take a look at the conservation of mass assignment. So on the last lab, we looked at our flask. When we mixed two different reactants together, their mass still stayed the same. So let's see what we can do today with this. So we have H2, which is a diatomic hydrogen, and O2, diatomic oxygen, making water. So we want to see if this is balanced or equal mass on both sides. So here we have our hydrogen, 1, 2. So we have 2 hydrogen, and we have 1, 2 oxygen, as it says above. If now we want to do the molar mass from the periodic table. So if there's 2 hydrogen, 2 times the mass of hydrogen will equal 2 grams. With our oxygen, there's 2 times our mass of 16 is going to equal 32 grams. That's our reactant side. So total 32 plus 2, our total would be 34 grams. Now we want to see if that's equal to our H2O. So here we have 2 H's, 1 oxygen. That's how many we're counting. So look right now and see, are they the same on both sides? Are they the same hydrogen and the same oxygen present? Then we're going to find our mass. If we have 2 hydrogen plus 1 oxygen, we have 16 plus 2 will give us 18 grams as our total mass. Does 18 grams equal the 34 we started with? So that's not equal. 34 and 18 are very different. What needs to change to show that mass is conserved? Mass can be reformed, but it can't come out of nowhere or disappear. So where did that extra 16 grams go from our reactants to our products? So here, we're going to have to see how many we need in the before and how many we need in the after. So we know that's not equal. We're going to need at least 2 oxygen, because there's only 1 over here and we start with 2. So let's see if we can double our molecules made. Now we have 1, 2 oxygen, which matches our 2 oxygen on the other side. This side has 2 hydrogen, this side has 4. So we need them to be equal. So we're going to have to add another hydrogen. So now we have 1, 2, 3, 4. Now both sides, 4 hydrogen and 4 hydrogen, before and after, 2 oxygen and 2 oxygen. Now we're balanced on our number of atoms. Let's check out our mass. So instead of, for H2, we have 2 hydrogens and 1 oxygen. So we do 2 times 4, because there's 1, 2, 3, 4, or sorry, 4 hydrogen times 1. So there's 1, 2, 3, 4 of them with a mass of 1. So that would equal 4 grams. And then our oxygen, O2, we have 1 of those O2s. So 2 times 16, 32. 32 plus 4 is going to be 36 grams. Over here on our reactants, that's our before. Now our after, we have 2 water molecules, and we know our water molecule is 18 grams. So if you have 2 of these, that's going to be a total of 4 hydrogen, because you're doubling it. So 1, 2, 3, 4 hydrogen, plus 1, 2 oxygen. This big 2 tells me that there's 2 oxygen here. So 2 times our 16. So 32 plus 4, 36 grams. So is our mass equal now? 36 and 36. That looks different than 34 and 18. So how would these changes affect the chemical equation? So now we're going to count up here and see if we have the right number of the molecules present. So in our reactants, I have 1 O2. That's correct. There's 1 O2 here. You don't show a number 1 in front of it, but there'd be 1 O2. There's 1, 2 H2s. So now you have to go add the coefficient in front of the H2, meaning there's 2 H2 molecules, a total of 4 hydrogen. This is a total of 2 oxygen. And then H2O, there's 2 water molecules. That means there's technically 4 hydrogen total and 2 oxygen total on the other side. That's our balanced equation. And again, you don't need to write the 1, just if it's more than 1, then you write it. And that's how we do our conservation of mass. Your reactants have to be equal to your products.